question of whether the code explicitly mentions the minimum depth for installing 13.2 kilovolt primary cables does not have a straightforward answer. After reviewing common electrical codes and standards, it appears that a specific, universally mandated minimum depth for 13.2 kilovolt cable burial is not explicitly detailed in the way some might expect. However, this does not mean that depth considerations are absent. Instead, the requirements for burial depth are derived from a combination of factors and often involve referring to multiple sections within the relevant codes as well as local regulations and engineering judgment. Firstly, the National Electrical Code, or NEC, although widely adopted, might not provide an exact burial depth figure for 13.2 kilovolt cables in every situation. Instead, the NEC focuses on safety and protection of the cables from physical damage. The specific article you would want to reference would be Article 300.5, which deals with underground installations. This article details requirements for direct burial cables and raceways, and it provides a table that specifies minimum burial depths based on voltage and installation type. However, the provided tables in Article 300.5 might not directly address 13.2 kilovolt systems. For voltages above 600 volts, the code often refers to engineering supervision and specific installation requirements determined by qualified personnel. This means that the determination of appropriate burial depth is left to the discretion of qualified engineers and local authorities who can assess the specific conditions of the installation site. Secondly, local codes and regulations often supplement the NEC and may provide more specific requirements for burial depths. It is essential to consult the local utility company and the authority having jurisdiction, or OJ, in the specific area where the installation is planned. These entities may have established standards and guidelines that mandate certain burial depths for high-voltage cables to ensure public safety and prevent damage to the electrical system. These local regulations may take into account factors such as soil conditions, climate, and the potential for mechanical damage from digging or construction activities. Thirdly, the type of cable used and its construction can influence the required burial depth. Cables that are directly buried, meaning they are placed directly in the soil without any protective conduit, must be designed and rated for direct burial. These cables typically have a rugged outer jacket that provides protection against moisture, chemicals, and physical abrasion. The manufacturer's specifications for the cable should be consulted to determine the recommended burial depth and any specific installation requirements. Cables installed in rigid metal conduit, intermediate metal conduit, or rigid non-metallic conduit may have different burial depth requirements as outlined in the NEC. Fourthly, soil conditions and environmental factors play a crucial role in determining the appropriate burial depth. In areas with rocky soil, it may be necessary to provide additional protection for the cable, such as a layer of sand or a concrete encasement, to prevent damage from sharp rocks. In areas subject to freezing temperatures, the burial depth must be sufficient to prevent the cable from being damaged by frost heave. The depth should be below the frost line to avoid stress on the cable caused by the expansion and contraction of the soil. Fifthly, the presence of other underground utilities must be considered when determining the burial depth. It is essential to contact the local one call center or utility locator service before digging to identify and mark the location of existing underground utilities such as gas lines, water pipes, and communication cables. The NEC specifies minimum clearances between underground electrical cables and other utilities to prevent accidental contact or damage. These clearances must be adhered to when determining the burial depth of the 13.2 kilovolt cables. Sixthly, engineering judgment is paramount in situations where the code provides general guidelines but does not offer specific requirements. Qualified electrical engineers must evaluate the site-specific conditions and make informed decisions about the appropriate burial depth. This evaluation should consider factors such as the type of soil, the presence of other utilities, the potential for mechanical damage, and the need for future access to the cable. The engineer should also consider the long-term reliability and safety of the installation. Seventhly, proper marking and identification of the buried cable are essential to prevent accidental damage during future digging activities. The NEC requires that underground cables be identified with warning ribbons or markers placed a specified distance above the cable. These markers should clearly indicate the presence of a high-voltage cable and provide contact information for the utility company or owner of the cable. The markers should be durable and resistant to weathering to ensure that they remain visible for many years. Eighthly, regular inspection and maintenance of the underground cable system are necessary to ensure its continued reliability and safety. The utility company or owner of the cable should conduct periodic inspections to check for signs of damage or deterioration. These inspections may involve visual examination of the cable termination points, testing of the cable insulation, and monitoring of the cable's performance. Any problems detected during these inspections should be promptly addressed to prevent further damage or potential hazards. Ninthly, it's important to consider the specific application and the load the cable is intended to serve. For instance, a cable feeding a critical facility might warrant a deeper burial depth or additional protection measures compared to a cable serving a less critical load. The reliability requirements of the system should influence the design and installation practices. Tenthly, documentation is key. All design decisions, including the rationale for selecting a particular burial depth, should be thoroughly documented. This documentation should include site surveys, soil testing reports, coordination studies with other utilities, and any engineering calculations used to determine the appropriate burial depth. This documentation will be valuable for future maintenance, repairs, and upgrades to the electrical system. In summary, while a single explicit code reference for the minimum burial depth of 13.2 kilovolt cables may not exist, the determination of an appropriate depth relies on a comprehensive assessment of multiple factors including adherence to NEC guidelines, local regulations, cable specifications, soil conditions, the presence of other utilities, and sound engineering judgment. Consulting with local authorities and qualified engineers is crucial to ensure a safe and reliable installation.